All right, so moving on to Unit 4. Unit 4 was over angle relationships, okay? So, first question is asking about vertical angles. So remember, vertical angles are those angles that are across from each other. Where two lines cross. Okay, so they don't take into account these parallel lines here. All they care about is two lines crossing. So if I'm looking here at A, the vertical angle with A would be angle D. So I could say angle A and angle D would be vertical angles. And the same way that B and C would be angle B and angle C would be vertical angles. Now, so there's two pair of vertical angles for each time lines cross, right? There's two across from each other here and two across from each other here. So same thing for my other intersections. I could say angle I and angle K would be vertical angles, and then angle J and angle L. Those would be vertical angles. And then for my next one, if I'm going up here, I could say angle E and angle G are vertical angles, and then the other ones, angle F and angle H. And then we have my last one, so angle M and angle O, and then angle N and angle P. Okay, so those are all my vertical angles pairs at every intersection. So remember that vertical angles, those are across from each other. They will always be across from each other where two lines cross. Okay, now this next one says line M, so here's M, is parallel to line N. So remember that the parallel symbol, I'm just going to put this here, is these two lines that are right next to each other. Okay, we want to name all the alternate interior angles. So let's talk about what alternate means first. Okay, so alternate, I'm going to write this off to the side. Alternate means that they're going to be on different sides of the transversal. Now, what is a transversal? Okay, so transversal is really just any line that crosses through any other two lines. Okay, so line P, that would be my transversal. So transversal, that would be line P. And it just passes through two lines. Okay, in our case, they are parallel lines, but they don't have to be. You don't have to have parallel lines for you to have these relationships. But we will talk about when they are parallel, what kind of outcome you get when you do that. Okay, so first we're going to talk about alternate interior. So we talked about alternate. Now, alternate is, they're different sides of the transversal. So like 4 and 7, those would be on opposite sides of my transversals. 4 is on the left, 7's on the right. So those would be two different sides of my transversals. So they would be alternate. Interior means that it's going to be inside of my parallel lines or any two lines that you have. So here would be interior, right? Because here are my two lines. So the inside, that would be my interior. So everything in there would be interior. Now my exterior is going to be the opposite of that. Okay, so I'll have exterior. So anything on the outside, and I'll have exterior over here as well. So any angles that are on the outside, those are going to be exterior angles. Okay, so alternate interior angles, those are going to be ones that are inside my parallel lines, but they're on opposite sides of my transversals. So if I'm looking at angle 4 is right here. So it's alternate interior angles, the one that's inside but on the opposite side of the transversal would be angle 6, okay? And angle 6. So we don't want to choose angle 3, even though it is both inside and on opposite sides of my transversal. because we want to have one angle on one of my parallel lines and one angle on the other parallel line, okay? We don't want them to share this line. We only want them to share the transversal. So see how they both touch the transversal, but they don't touch the same line right here? That's what we want. We don't want them to touch the same lines. We don't want them both to be on M or both be on N, okay? And then my other pair of alternate interior angles would be angle 3 and angle 5. All right, so this next one says line Q and S is parallel to line TV. So here's QS, and it's parallel to TV. Okay, so we want to name all the alternate exterior angles. Okay, so just like we did with alternate interior angles. Okay, so we want on opposite sides of my transversal, but this time I want them on the outside. So here's my interior. So I don't want any of those angles that are inside my two parallel lines. I want them on the outside. So remember, when we have angles like this, I can't just name them all angle R, because angle R could be this angle, it could be this angle, it could be this whole angle, this one and this one, this whole side. It doesn't really tell me location. So we can also name angles with 3 letters. And remember, when we name them with 3, the actual location of the angle is located with the second letter. So if I want my angle to be actually located at R, so say let's do this angle right here. I want R to be the middle letter, so R. And then it doesn't matter which direction I go, but I can go Q, R, P, or I can say P, R, Q. Doesn't matter. So I'm going to go Q, R, P, and then we got to give it its little angle sign. Okay? So that's talking about this angle right here, angle Q, R, P. R will tell you the actual location, and then the 2 letters on the outside will tell you which part of that angle I'm encompassing. I'm only taking up from Q to P. And now we want the other alternate exterior angle, okay? Oops. And, okay? So it's talking about on the opposite side. This is on the left side of the transversal. So I want the one that's on the right side of the transversal, okay? So I'm going to talk about this angle right here. And again, we're located at U. So I'm going to go ahead and write U. And then I'm going to go ahead and just call it WUV. But you could also call it BUW. It doesn't matter. All right, and then I have one more pair. So this time I'm going to choose the one on the right side. So I'm going to call that angle P. Whoops. Angle PRS. And then that will be with angle right here, which is going to be, let's call it angle TUW. But you could also call it WUT. Doesn't matter. Okay, so those are my alternate exterior angles. Now, when my lines are parallel, as they are in these 2 instances, if my lines are parallel, when it says the word alternate, you can assume they are congruent. So if I have alternate angles, alternate, and parallel lines, then those angles are congruent. Are congruent. Okay, so remember, congruent means they are the same. Okay, so I'm just saying that if I had these 2 angles and I had an actual measure, say that this angle PRS, that's 120 degrees. If it's 120 degrees, then I know that this angle right here, TUW, would also be 120 degrees because they are alternate interior angles from parallel lines, okay? So those 2 would be congruent, and the same thing if I did my alternate interior angle. So if I had said angle 4 is 50 degrees, and I said angle 6 is 50 degrees, that would be true. They would be congruent, okay? Because my lines are parallel, and they are alternate interior angles, okay? So this one right here says line M is parallel to line N. Name all the same side interior angles. And then we want to know if angle R is equal to 4x minus 2 and angle 6 is equal to 2x plus 8. What is x equal? Okay, so this kind of goes back into what I was saying up here. That was alternate. Now we have same side. Okay, so same side, again, has to do with the transversal. So same side is going to talk about, they're going to be on the same side of the transversal. Okay, so that one should be pretty easy to remember since it has it in its name. Let me move that up a little bit. So it's same side interior angle. So we know that interior is the inside, is between my two parallel lines. Okay, so let's go ahead and just name all of the same side interior angles. So we went inside. So I have 4, 3, 5, and 6. Those are the ones that are inside. Now I want same side transversal, and remember I only want one on line M and one on line N. So I could say that angle 4 and angle 5, those would be same side interior. And then angle 3 and angle 6 would be same side interior as well. All right, so just like up here where I said that those angles, those alternate angles, those would be congruent. Same side interior, same side, any same side angles are going to be supplementary. Okay, so same side angles, when they have parallel lines, okay, they are going to be supplementary. And what does supplementary mean? Remember, supplementary means that they add to 180. Because what do straight lines add up to equal? Straight lines add up to equal 180 degrees. So my same side interior angles, if I were to break them off, if I were to tear these out, cut them out piece by piece, and I was going to cut out 4 and I put it right next to 5, they would together make a straight line. And then I would have a linear pair. Linear pairs are supplementary. They add up to 180 degrees, right? So anytime you see a straight line, you can assume that those add up to 180. So like 1 and 2, that would add up to 180. 1 and 4, that would add up to 180. 2 and 3 would add up to 180, and 4 and 3 would also add up to 180, okay? So if my lines are parallel, I know that 4 and 5 should add up to 180, and 3 and 6 should also add up to 180. So if I'm given a problem where there's same side interior angles and I'm solving for x, I'm going to do exactly that. I'm going to add them to 180, okay? So I know that angle 3 plus angle 6, 6 equals 180 degrees. So I'm just going to plug in what angle 3 is. That's 4x minus 2, 4x minus 2, plus what angle 6 is, 2x plus 8. And that should equal 180 degrees. Now, I'm going to combine like terms before I move anything. So I have 4x on this side and a 2x on this side. So 4x plus 2x gives me 6x. And then I have a negative 2 and a positive 8. So I'm going to go ahead and go 8 minus 2. That is 6, so plus 6. And that equals 180 degrees. Now that I have combined my terms on one side, I'm going to go ahead and move my constant, my 6, over to combine it with my 180. So I have a positive 6, so I'm going to subtract 6 from both sides, so minus 6. That gets rid of my 6, so it gives me 6x equals, and then 180 degrees minus 6. I need to borrow right here, so 7, 10. That 10 minus 6 is 4. Bring down the 7. We got a 1, so 174. And then I'm going to divide by 6. So 174 divided by 6 is, let me get my calculator. Okay, so we get 174 divided by 174 divided by 6 is equal to 29. So in this case, x is going to equal 29. All right. So be careful reading the instructions too, because in this case, it does ask me what x equals, but in some cases, they will ask you what the angle is equal to. So sometimes they might go back and say, okay, now what is angle 6 equal to? So then you would need to take your x and you would need to plug it back into wherever I have an x for that angle, and then solve for what that is, okay? All right. So next, on number 3, okay, it says line M is parallel to line L. We want to name all the same side exterior angles, okay? Okay, so same side exterior angle. So again, we want the same side of the transversal, and this time we want the exterior. So here's the exterior, here's the exterior. So I know I'm going to be looking at angles 1, 2, 7, and 8. But I want same side of the transversal. So if I'm looking, I want angle 1 and angle 7. And then angle 2 would go with angle 8. And again, just like I said on the other side, if they are same side, they're going to add to 180 degrees if my lines are parallel. In this case, they are parallel. So if it had wanted us to find a value, we would just add them up and set it equal to 180. Okay? Now, this next one is my special one because it doesn't have a same side or alternate. So these are corresponding angles, okay? Now, I'm going to tell you right now, if my lines are parallel, corresponding angles are going to be congruent. If lines are parallel, then congruent, okay? So corresponding angles, right here, corresponding, they're their own special, okay, because they're going to be kind of both things. So corresponding angles are going to be one inside the parallel lines, one outside the parallel lines, and they're going to be on the same side of the transversal. Okay, but don't let same side confuse you. They are going to be congruent if your lines are parallel. Okay, it doesn't say in this problem that, okay, so it doesn't say in words in this problem that they are parallel, but these little arrows on the line, that means that these lines are parallel. Here they are parallel. Okay, so those little, if you see those arrows on lines, that means that those lines are parallel to each other. So what it wants to know is name all the corresponding angles first, and then it wants to say if A is equal to 8x minus 5 and C is equal to 3x plus 10, then solve for x. Okay, so let's name all the corresponding angles first. So remember, we want one on the outside, one on the inside, and the same side of my transversal. So if I'm looking at angle D is on the outside, so I know I want an inside angle, and I want it to be on the same side of my transversal. And again, it's still the same deal where I want one angle on one line and one angle on the other line. So if I have angle D, I'm going to say my corresponding angle is angle B. And then I'm going to do this side, so angle H would go with angle F. And now I have C. C is on the inside, so now I want the outside angle. So it's going to be angle C goes with angle A. And then angle G and angle E. So that would be all my corresponding pairs. Okay? Now it says that you want if angle A is equal to 8x minus 5 and angle C is equal to 3x plus 10, then solve for x. So angle A and angle C, they are corresponding. So if something is congruent, we're always going to set it equal to each other. Okay, so because they're congruent, that means that they're the same, and we can set them equal to each other. So I'm going to say angle C is equal to angle A. C is 3x plus 10 equals 8x for A minus 5. All right, so now I'm going to get all my x's on one side and all my constants on the other. So since 3x is the smallest, I'm going to go ahead and just move 3x over. So minus 3x, whatever I do to one side, I have to do to the other. So get rid of that. That gives me 10 equals 8 minus 3, that is 5x minus 5. And then I'm going to add this 5 to both sides. So that gives me 10 plus 5 is 15. So 15 equals 5x. Okay, now I'm going to get rid of this 5. I'm going to divide by 5 from both sides. So x equals 3. Okay, and again, this says solve for x, but if I had wanted to find the actual angle measure, I could just take whatever I found x to be, and I could just plug it back in wherever I have an x. Now in this case, since these angles are congruent, I could put x into either one to find that angle. Whereas if I was doing one of the same side interior, same side exterior problems, I would have to make sure I put it in the correct angle because those angles are not the same. They are different, okay? Right, so last problem. It says line L is parallel to line M. So here's L and M. Notice they also included little arrows for you. So they are parallel. And the measure of angle 2 is 65 degrees. So I'm going to go ahead and label 65 degrees at angle 2. We want to know what the measure is from angle 5. Now, technically, angle 2 and angle 5, oops, let me move that up, sorry. Here's angle 2, here's angle 5. Technically, angle 2 and angle 5 are not related. They don't have a relationship that we would name. But if we know these lines are parallel, we could get there. Okay, so there's a couple different ways we could go about doing this. I could say that 2 and 6 are corresponding angles, so they are congruent. And then 6 and 5 are a linear pair, so they add up to 180. I could say that angle 2 and 7 are congruent angles because they're alternate exterior angles, and then 7 and 5 are linear pair. I could say that 1 and 2 are a linear pair. Find out what 1 is, because I know that they add up to 180. And then say 1 and 7 are congruent because they, oh, nope, they would be, 1 and 5, not 1 and 7, sorry. 1 and 5 and 1 and 5 would be corresponding, so then they would be congruent. Okay, so I'm going to go ahead and do that. I'm going to go and say that angle 2 and angle 1 are a linear pair. Okay, so linear pairs, they add up to 180 because they make a straight line. So that means angle 1 plus angle 2 equals 180. Okay, so I know angle 2 is 65 degrees. So angle 1 plus 65 degrees equals 180. Okay, so we're going to subtract 65 from both sides, minus 65. So angle 1 equals, I'm going to go ahead and do this off the side, 180, 65. I need to borrow, so 7, 10. 10 minus 5 is 5. 7 minus 6 is 1, and then bring the 1 down. So I get angle 1 is 115 degrees. So I know angle 1 is 115 degrees. All right? Now I can say that angle 1 and angle 5 are corresponding angles. So they are congruent. So I know that angle 1 equals, or it's also congruent, equals angle 5. So angle 5 equals 115 degrees. All right. So that is the end of Unit 4. Just make sure for the final you know all where my angles are located, my same side interior, same side exterior, alternate interior, alternate exterior, my corresponding angles, my vertical angles, and my linear pair. Know where they are located and then what it looks like. Are they congruent? Are they supplementary when my lines are parallel? Okay? And that is the end of Unit 4.